In the last video, I managed to break the servo of the TRX-6, and here it is. What I'm now going to do is simply open it up, unboxing of a different kind, and see what's going on inside. Sorry about the noises from the background. I have a bit of a creaky chair here currently. So let's open it up. I have no intention of putting it back together since I already ordered a new servo. You will see it in another video. Let's see how it will go with that one. But before that, I really want to see what happened with this one. And we can do also, actually, I will do also a short review of the true internals of this servo and what do I think about it. Okay, screws going through the whole thing. All aluminum, something I guess. Let's see what's hiding inside. Okay, there's some sort of gasket there. This. Oh, what looks to be. There's a motor, connectors. Okay. There's no others. Okay, this seems to be also, that's okay, yeah, open there, excellent. So what do we see there? This is a top cover, axle goes out there. The main axle after the gear. There's definitely, I would say it's metal specs, it's pieces of metal. Yeah, it's pieces of metal there. Let's see the gearing. What's gone wrong? Okay. Ooh. Okay, starts to explain a bit. Okay, here's the brass the ball bearing. Nice. These are completely stuck. I think I need to disassemble more of this. Checking this. And just going to snip off cables. Don't. Sometimes these chemicals, stuff is put inside, glues and so on, epoxy to protect things, sometimes prevent them from moving or vibrations, sometimes to prevent people from spying and seeing what's inside, different reasons. Okay, let's cut this off. This wire is annoying in the way. Okay, I think I need new pliers. Anyway, let's snatch something else up there. Let's get this one out of here. Okay, so what we see here. Okay, interesting. So this is the DC motor, brushed one. Nothing fancy there. Cheap one. Nothing special, to be honest. Here, more clicks. These are the sensor cables. So here's the microcontrollers, and they've at least lacquered them, coated them to prevent short circuit in case something goes inside. I managed to squash the capacitor there. Basic electronics, basically for receiving the signals from the transmitter or receiver, doing all kind of configuration things if it's possible, checking, controlling the angle of the motor and the axles, all that stuff. This is a potentiometer, so it's a plastic potentiometer which goes into the main shaft. It's somehow attached here. Yeah, so that's about it. Just plastic potentiometer, not anything digital, pulses, whatever. I don't understand why they do, but I don't know even if this was supposed to be digital anything or whatever, but yeah, some of these parts are probably crimped, so there's no other way than forcing them out by force. See what? Okay, there it goes. Let's go to the next one. Okay, more pieces of metal here and there. Here's the shaft. This comes from the motor, really thin one. And there's the sprocket which goes directly to the motor axle. That looks fine. Then it's this main one here. Okay, here seems to be one of the reasons. When you design a motor to apply a certain amount of torque, it usually, the controller, meaning this one, should have limits that it's able to limit, like, the mechanics, whatever is behind it is now, or electricity's power supply is not able to provide enough power, or whatever is able to take enough torque, that it will limit it. I guess not in this case. Since it's cheap, I don't know if it even actually measures the current. Maybe it does, maybe not. Or in case of angles, it should have limits there programmed to which beyond it cannot go, and it will just not apply torque. But if the system is supposed to be able to provide a certain amount of torque, it's irrespective if it's in the end of an angle pushing against something, it's supposed to be able to last that for quite a long time, because if it's its nominal value, it's supposed to be in constant use. So this one definitely, I can feel that the potentiometer is not a continuously rotating one. It's with an angle, so maybe I just pushed it too far and broke this one, but there's no protections against it. But in that case, it should have just theoretically broken this potentiometer, not the sprockets, unless the sprockets are badly made. Okay, this one appears to be steel. There's bearings. These steel ones appear to be, yeah, perfect, no problems whatsoever. Then let's look at the brass parts. This is the key point. Okay, this one looks to be steel. I don't know if you can see it, but I'm inspecting from another angle. Perfect. Nothing broken. Here comes the one with lots, I don't know if you can see, but it's got a lot of flakes of metal. Okay, the top sprocket, which seems to be stamped together. It looks to me like it's steel. Then it's the brass one. Sorry about that one. There are some pieces. It seems to be a bit worn out in certain spots, but not that bad. So let's see what this one says. Axle. It's got a steel sprocket, I think, which looks okay. Fine. Combined with a brass sprocket, which is stamped basically on top of that one. I mean, this part here already could give out. But nope, there's the culprit. Brass, 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 and this angle here, all the teeth of this sprocket are completely gone. Yeah, and interesting, you can see there's an edge here which is still remaining, meaning they were not properly when aligned. So this whole thing was stripped out. So this is interesting. Why they use brass? Brass is good for many things, and admittedly it's been used in clock mechanisms, all kind of fun mechanisms with sprockets for, I would say, probably longer than steel has, but it's obviously not able to take the load. It's just stripped off all the teeth. So is this a culprit? No, they're definitely not using plastic parts, but they're using brass. Interesting question. Why steel, then brass? Did they deliberately make certain parts brass so they'll be weaker, cheaper? I mean, that's interesting to know. Nothing wrong with brass itself, but brass is not suitable for certain things, where steel is better and so on. So Let's assume they chose these ones and they measured these, are able to take the torque this is supposed to provide. Just my personal opinion, I doubt that seriously. Why then put brass parts here? And did they really evaluate these would last? Based on what I see, these are just case of cost and cheapness. I still don't entirely see the point of why this had to happen, unless they are promising a lot more torque out of this motor than this can tolerate. This is just sheer cutoff. So bad quality, cheap, don't care, bad alignment of sprockets, don't know. Definitely a cheap motor. What's costing these ones so much? I guess the making of these aluminum casings costs somewhat. But despite the aluminum casing, the nice support bearings, let's see where the bearings went now. Despite all of this nice, it didn't really matter as there was one weak point in the whole chain. This one. Okay, that's about the unboxing of this one. Now I know what happened. Sprockets, brass one, stripped off its teeth. Thank you for watching. Put like, dislike, subscribe, all that stuff. Thank you. See you next video.